Ever wonder how scientists figure out the size of massive earthquakes? It's not just about the shaking, right?
Exactly. It's about the energy released. And that's where things get really interesting.
This paper dives into the February 6th, 2023 Turkish earthquakes, a double whammy.
Two huge quakes, back to back. The scientists used a really cool method to measure their power.
And they got some surprising results. Let's unpack this. So remind me again, what happened in Turkey on February 6th, 2023?
Two massive earthquakes hit south-central Turkey near the border with Syria. Devastating.
And the numbers varied wildly, right? Different organizations reported different magnitudes?
Absolutely. There is a range of about 0.2 magnitude difference in the reports. That's a significant variation. Wow.
So how do these researchers tackle the problem of inconsistent measurements?
They used a new method focusing on long-period coda waves. Think of it as the lingering echoes after the main earthquake waves.
Coda waves? I've heard that term before, but I'm not sure I fully understand it.
It's the seismic energy that keeps reverberating after the initial shock. It's like the aftersound of a really loud explosion.
So they're using the aftersound to measure the initial energy?
Precisely. Their method is designed for really big earthquakes, minimizing the effects of things like complex rupture processes. Right.
And what did they find? Did their method give them a different answer?
Yes. They calculated moment magnitudes of 7.95 and 7.86 for the two earthquakes. Higher than previous reports.
Wow, significantly higher?
Yes, larger than all previous reports. The first quake was slightly bigger than the second by about 0.11 magnitude.
So the initial reports underestimated the size?
It seems so. Their method provided a more robust measurement.
How does their method compare to other ways of measuring earthquake magnitudes?
They compared their results to those from organizations like GCMT and USGS. Theirs were consistently higher.
So their method is more accurate?
It appears to be more accurate for these very large events, but there are always systematic differences between different magnitude types.
Did they discuss any uncertainties or errors in their measurements?
Yes, they acknowledged that the standard deviation was relatively large, about 0.2, but the standard error of the mean was small, around 0.01.
So the average was precise, but individual measurements varied?
Exactly. They attributed this to factors like the shorter time window used to avoid contamination from the second earthquake. Makes sense.
Anything else that might have affected their results?
They noticed variations in their measurements depending on the direction of the seismic stations relative to the earthquake epicenters.
So the direction mattered?
Yes, the energy radiated differently in different directions, but they had enough stations to get a reliable average.
What are the broader implications of their findings?
Their higher magnitude estimates provide a better understanding of the total energy released. This is crucial for hazard assessment and building codes.
So it's not just about the number, but what that number means for future preparedness.
Precisely. It helps us better understand the potential for future earthquakes in the region.
What makes their method so effective for large earthquakes?
It uses long-period coda waves and a longer time window, which helps to minimize the effects of source complexity and propagation effects.
So it's less sensitive to the messy details of the earthquake itself?
Exactly. It gives a more robust estimate of the total energy released.
What kind of future research could build on this work?
Further refinement of the method, testing it on other large earthquakes, and exploring the implications for seismic hazard assessment.
So more data, more testing, and more practical applications.
Precisely. This is a significant step forward in earthquake science.
Were there any limitations to this study?
The shorter time window used to avoid contamination from the second earthquake might have introduced some uncertainty. Also, the method needs a good azimuthal distribution of seismic stations.
So more data would always be better?
Always. More data, better distribution, and more testing would improve the accuracy and reliability of the method.
So to wrap it up, what's the big takeaway from this paper?
It presents a new, more accurate method for measuring the magnitude of large earthquakes, providing crucial information for understanding seismic hazards and improving preparedness. The higher magnitudes calculated for the Turkish earthquakes highlight the importance of using robust methods for accurate assessment. Right.
That was a great discussion. Thanks for breaking down this fascinating research.